The explosion of the Deepwater Horizon platform resulted in the release of an estimated 205 million gallons of oil into the Gulf of Mexico in a 3-month span. The impacts of any oil spill can be devastating, affecting the ecosystem and any associated person or business. While human intervention is necessary and most methods of cleanup are environmentally friendly, the use of chemical dispersants is one such method that is controversial. With 2 million gallons of oil dispersant used in the Gulf of Mexico since the Deepwater Horizon accident, dispersant use is an important topic for anybody to be familiar with. By the end of this movie, you should understand what dispersants are, how they work, and that dispersants are potentially harmful to the environment. Simply put, dispersants accelerate natural oil degradation by breaking down oil into small droplets that are easier to degrade. These processes include the combined interaction of weathering, evaporation, oxidation, sedimentation, and biodegradation. These processes degrade the estimated 168 million gallons of oil that is naturally released into the marine environment every year off of U.S. shores. Weathering involves the combined action of currents, temperature, waves, wind, and other environmental aspects that will break down oil both physically and chemically to form droplets. Evaporation occurs when the liquid component of oil is evaporated into the air. Oxidation is the chemical transformation of oil components, which allows oil to combine with water molecules, which ultimately results in oil breakdown. Sedimentation is the process by which oil combines with suspended material and then is deposited on the sea floor. Simultaneously with these other processes, biodegradation occurs, which involves microorganisms that break down oil. The oil is broken down into non-toxic compounds. Each of these processes is aided by every other process. Again, chemical dispersants accelerate oil degradation by working in unison with the natural processes to ultimately degrade oil into non-toxic compounds. Dispersants may sound like a good idea, but are dispersants actually effective when it comes to oil degradation and dispersion? The answer is yes, as it was found by researchers from the Department of Civil and Environmental Engineering at the University of Cincinnati. An Environmental Protection Agency approved baffled flask test was used to test the effectiveness of dispersants. The relationship of dispersants with different environmental conditions could also be determined due to the ability to isolate specific tests in flasks. These conditions include temperature, oil type, and water conditions. Water conditions are the mixing energy of currents, waves, and wind, which were simulated by swirling and shaking the flasks at different speeds. Dispersant effectiveness could be tested for by comparing results to a reference test, or control, that did not contain any chemical dispersants. Multiple flasks were used for each test and then replicated multiple times to ensure that data was randomized and any findings could be determined as statistically significant. After extensive testing, dispersants were effective in breaking up oil slicks and forming small oil droplets. It was also experimentally proven that dispersant effectiveness significantly enhanced when combined with other external factors. The combination of vigorous water conditions and an increase in temperature led to further increases in oil degradation rates. Although dispersants are effective in oil degradation, the environmental effects have been highly debated. First off, it has been stated by many that dispersants are non-toxic to most species, and that dispersing oil will only have a more positive effect on ecosystems. Some believe dispersants cover up the obvious effects of a spill by reducing the amount of oil that gets to shore, but leads to further problems of the ecosystems out at sea that encounter the dispersed oil. More research is needed on the effects of dispersants, as there have been no long-term studies on the effects of ecosystems. Remember, dispersants accelerate natural oil degradation. The natural processes that degrade oil include wind, waves, current, temperature, sedimentation, oxidation, and biodegradation.